In example 3, we have several lines that we need to graph. We're going to graph using a table of values. Here's our relationship, here's our equation. You get to choose the x values. You just need to pick some between -10 and 10. And if they produce a y value that's off the graph, then what you'll need to do is just pick a better x value. But I think we're going to go with -2, maybe -1, 0, and 1. When x is -2, if we want to know what y is, we can simply substitute x into the equation. So this is -4 minus 6, which is -10. Barely on the graph. -1 is the next one. So we'll just take out the x and substitute in what we'd like it to be. So that's -2 minus 6, which is -8. 0 is a nice one to use. Try to line these up a little bit. Because anything times 0 is 0, then we've got 0 minus 6, which is -6. And you're seeing here as we increase by 1 on the left-hand side, we are increasing by the same amount. You could also be decreasing by the same amount, but the key is that it's the same amount. So if you have a given increase or decrease in x, you'll have a corresponding, it'll be the same increase or decrease, and by the same I mean, it could be different between the x and the y, but it will be constantly the same thing. The next one will be 1, so it'll be 2 times 1 minus 6, that's 2 minus 6, which is -4. We can plot our points now. -2, -10 is down here. -1, -8 is here. 0, -6. And 1, -4. And if you wanted to, you could plot some more points, and that would increase the accuracy of your line. You can see here that we're just going up 2, right 1 every time. So you could plot some more points if you really wanted to. I like to figure out where the end of the graph's going to be, and that'll make my line nice and straight. And remember to include your arrowheads. Draw the line the entire length of the graph. All of these points will also satisfy this equation. There's actually an infinite number of them that will work for this equation, but there's lots that won't. Anything that's not in the graph, that x and y is not a solution. Let's try B. We're going to do the same thing here. Maybe we'll choose -1, 0, 2, and 4 just to be a little different. So this time the x is here, so we'll have -1 is equal to y plus 1. Then we'll need to subtract 1 from each side. So y will be -2. Be careful where the variable is you're substituting. Sometimes the y is on the left by itself, sometimes it's not. The next one is going to be 0, so 0 is equal to y plus 1. We'll subtract 1 from each side, and y will be -1. 2 is the next one. 2 is equal to y plus 1, so we'll take away 1 from each side, and y will be 1. 4 is equal to y plus 1, subtract 1 from each side, and y will be 3. Let's plot these points and see if they line up in a straight line. We hope that they do. And 4, 3 would be up here. Looks like they all are in a straight line. I'm just going to extend this a little bit. I know that this line has a slope of 1, and it cuts right through each one of these boxes here. So there we are. And we've got one last one here for example 3. So let's choose maybe -2, 0, 2, and 4. Maybe those will work, don't know. So we've got -2 times -2 plus y is equal to -3. So this is 4. So we're going to have 4 plus y equals -3. Subtract 4. Y is -7. 0 is the next one. -2 times 0 is 0, so we know that y is -3. We'll do 2 now. -2 times 2 plus y is -3. So we'll add 4 to each side, and y will be 1. 4 will be the next one. So we'll add 8 to each side here. Y will be 5. Plotting these points, -2, -7, 0, -3, 2, 1, and 4, 5. And they all do line up in a straight line.